Okay, so I want to work through a problem, and maybe we'll somewhat mimic the thought process Dijkstra had as he created his famous algorithm. So here I've got a list of different airports, and I actually have a graph that represents how these different airports are connected together. And we're going to try and find the minimum flying distance to get from one to the other. So maybe we're trying to reduce cost based on total fuel, which is proportional to distance. So with the single source shortest path, we have to have our source, our start point. So I'm going to go ahead and start here at San Francisco. And we're going to keep track of a couple of different informations as we proceed through this algorithm. So for all of these other airports, which we can't see where or how they're connected just yet, we'll keep track of the best possible distance to get to that particular airport. We're also going to keep track of the predecessor node, which is basically the node that we are at right before we arrive at a particular airport. So for example, if we go to O'Hare in Chicago, we'll keep track of whichever airport we came in from. And we'll use these predecessor nodes to basically define the path. So we'll be able to kind of work backwards and figure out a particular path when we're all done just by traversing through the predecessor nodes. Okay, so at the beginning, we don't really have a whole lot of knowledge. We know we're at San Francisco, and so I'm going to say that that's a distance of 0 away. And these other airports, we don't know, so we're going to use some sort of a sentinel value. So I'm going to go ahead and use the concept of infinity, which is kind of hard to read here. And as we get more information, we'll update these estimates. So these are just estimates until we're completely done processing a particular airport. Okay, the other thing that's kind of interesting here is we're going to assume that we have a whole team of people and we can kind of explore a bunch of different paths simultaneously. Okay, so the first step of Dijkstra's algorithm, as we'll see shortly, is initialization, where our source has a distance of 0, and our other airports or other locations, other vertices, are considered to be infinitely far away until we know more. Okay, so from here on out, we'll proceed in steps, and we'll proceed until each vertex of the graph is processed. In order to process a vertex of the graph, we will look at all of the outgoing edges, and we'll see if taking that edge will get us to the destination at a lower distance than our best known distance so far. So let's go ahead and start with San Francisco here. So we'll look at all the outgoing edges from San Francisco and all the places we can get. So we'll go through those edges in no particular order, and we'll see if we have an improved estimate. So I can go from San Francisco to Boston in 2,500 miles. Oh, that's definitely a bit better. So we'll update our estimate. And every time we update our estimate, we'll also update, 2,500. We'll also update the node that we came in from. So if we take that arc, we'll come into Boston from San Francisco. Okay, so we could also go to O'Hare at 1,800 miles. That's better than infinity, so we'll update that. And again, SFO will be our predecessor to Dallas-Fort Worth at 1,500, so we'll update that. And again, SFO is our predecessor. And to LAX from San Francisco, we'll only take 300 miles. And again, that's if we come in from San Francisco. Okay, so we've now processed all those outgoing edges. Now we have to decide what we want to do next. So imagine that we've sent a team to each of these different places, and they report back to us. And the people at LAX say, hey, it only took us 300 miles to get here. So what we're going to do is we're basically going to process these in order based on lowest first. So we're going to prioritize the things that are closest to us. Okay. So that means next we'll start from LAX. So at this point, we're completely done with San Francisco. We know that our best possible distance is 0, and we'll move on to our next node. Okay, so now we're going to repeat this process at LA. So we'll basically look at all of the outgoing edges, and we'll see if getting to the destination from that outgoing edge is less total distance. Now, here's where we have to be a little bit cautious. We're looking at the total distance from San Francisco. We've already invested 300 miles of travel to get to LAX. So our total amount of travel will be this 300 plus whatever the edge cost is. So let's go ahead and look at the outgoing edges from LA. So we'll just look at them one at a time. So I could go from LA back to San Francisco. That would add another 300 miles. So our total would be 300 plus 3 to get to LA, and then 300 to get back to San Francisco. That'd be a total of 600. That's not any better than what we've already found. So let's look at the other edges. So I could go from LA to Dallas, so that would be 1,100 more miles. So our 300 miles to get to LA plus our 1,100 more would be 1,400. Oh, that's actually better than what we know so far. So we'll update this entire row. We'll basically update the fact that we can actually get there with 1,400 miles total distance if we go through LA. Okay, so we've processed that outgoing edge. By the way, I'm also going to kind of check off the outgoing edges as I process them, just to make sure as I'm working through this on paper that I don't miss anything. So we also have the outgoing edge to Miami, so that's 2,300 miles. Plus the 300 that we've already spent, so 2,600 total to get to Miami. That's definitely better than infinity, so we'll update that so we can get to Miami with a total of 2,600. And that's if we go through LA. So I'm going to go ahead and check that off. Okay, and once again, we've processed all the outgoing edges, so we're done processing Miami. So let's go ahead and move on. So let's look at our remaining cities and try and find the one that's considered closest to us. So Boston, 2,500, Infinity, 1,400, Infinity, 2,600, 1,800. Okay, so it looks like Dallas is our best bet here. So that's the one we'll process next. So we'll go ahead and look at all the outgoing edges from Dallas. So that leaves us with this. So just like before, I'm going to go ahead and our total distance to Dallas is 1,400. I'm going to go ahead and look at all the outgoing edges. We could go back to LA, but that would, we've already come through LA, so that's actually going to be a higher cost. So I'm done with that one. We could go back to San Francisco, but we started there. That distance was 0 total, so moving it up to 1,400 plus 1,500 would be 2,900, much worse than 0. Let's look at our flight to O'Hare. So 1,400 to get to Dallas, another 800 to get to O'Hare, that's 2,200. That's worse than 1,800, so we're not going to do an update there. Let's see, to get to JFK, so we will have already flown 1,400. Ooh, another 1,400 takes us up to 2,800. Oh, but we did, that's better than Infinity, so we'll go ahead and update. And with that, if we go through DFW. Okay, so we're done with that one. And now we'll look at the outgoing path to Miami. So Dallas is 1,400 miles to travel, plus another 1,100 is 2,500 miles of travel to get to Miami. Oh, that is better than what we've already got, so we'll go ahead and update that as well. So 2,500 miles if we go through Dallas-Fort Worth. Okay, so let's continue the process a little bit further. So we've now processed Dallas, and we're going to continue taking the lowest value, the highest priority of distances remaining until we've processed all of the possible nodes. So at this point, we've got Boston is 2,500, JFK is 2,800, Miami's 2,500, and O'Hare is 1,800. So it looks like O'Hare is our best bet here. So let's go ahead and consider O'Hare next. So going back to San Francisco is going to add 1,800 onto the 1,800 it takes us to get to O'Hare. That's kind of crazy. Going 800 more to Boston takes us to 800 plus that 1,800 plus the other 800 would be 2,600 to get to Boston. That's no better. Taking another 600 to get to Baltimore would take us to 2,400 to Baltimore. Oh, that's the first time we've been able to find a path to Baltimore. So we'll go ahead and check that off, and that's if we go through O'Hare. Okay, let's see, and then we've got one more outgoing edge going back to Dallas. So That would add another 800 miles onto our 1800 so far, 2600. That's worse than our 1400 we already had, so we're done processing that. And with that, we've completely processed O'Hare. Okay, so at this point, we've just got 3 more nodes to process. It looks like Boston is 2500, Baltimore is 2400, Miami is 2500. So we'll go ahead and do Boston next. So I'm just going to go ahead and remove the remaining edges here. So we'll work around Boston. So going back to San Francisco, of course, is not going to be, oops, I'm sorry. We'll work around Baltimore. Going back to O'Hare is not going to help us at all. Another 900 miles to get to Miami. So let's see, we're at 2400, so that'd put us up to 3300 to get to Miami. That's no better than what we've already got. Okay, so at this point we're done with Baltimore. So we've still got Boston, JFK, and Miami. Boston and Miami have the same priority. It's the lowest value, so it really doesn't matter which one we deal with. I'm going to go ahead and do Boston first. So going back to San Francisco would add another 2,500 miles onto our 2,500 we've already paid, which is more than 0. Don't need to do that. Another 1,200 miles to get to Miami would take us to a total of 3,600. That doesn't look any good. Another 200 miles to get to JFK. That would put us to a total of 2,700 to get to JFK. Oh, that's a bit better. So we'll go ahead and update JFK here. So if we go through Boston, it takes us a total of 2,700 miles. Okay, so we're now done processing Boston. Now we've got both JFK and Miami. Miami looks like our best bet, lowest total distance. So it's 2,500 miles away from San Francisco. If we go through Dallas, it would take another 900 miles to get back to Baltimore. So that's 3,400. That's no better than what we found so far. Another 1,200 miles to get back to Boston. So that would be 3,600, and that's no good. Another 1,100 miles to get back to Dallas. That's also 3,600, no better than 1,400. And then another 2,300 to get back to LA. That's also no good. So at this point, we're done with Miami, and we can go and process JFK, and we'll basically find that we've already identified our best possible paths. So when we're all done, we processed each vertex once. As we were processing each vertex, we had to look at all of its outgoing edges and the corresponding destinations. We had to see if the total distance, the distance to get to that vertex, and then adding on the edge cost to get to the vertex on the other side, if the total distance was better, we improved our distance estimate, and we also updated our description of predecessor. So if we wanted to find a particular path, we could basically traverse from the predecessor list backwards to our origin airport. So just as an example, let's figure out what our best path is from JFK. So if I want to start at JFK, the predecessor to that is Boston. And now let's look up Boston. Boston's predecessor is San Francisco. So our path is actually the reverse of this. So we'd start at San Francisco, we'd go to Boston, and then we'd go to JFK. Okay, and the total distance would be 2,700.